All right, let's start today's class. Can you see the screen?
Yes, sir.
Okay, so I think in the last class we were talking about this, um, that one, marginal PMF I talked about, and then we have actually, I think we have solved this one, and today I think we already we have solved this one as well. Joint PDF, and then this problem we have solved, value of C. All right, today I think we will start with this marginal PDF. Okay, so with this marginal PDF, uh, you can understand that marginal PMF, how did we solve? Similar case actually is in the marginal PDF as well. From the um, okay, from this joint PDF, from this joint PDF, we are talking about this marginal PDF. Okay, so if I take a particular variable taking all the values of y, then actually we are getting the fx. When I'm talking about taking all the values of x, then actually I'm getting the fy. Okay, so our idea is to find out the marginal PDF, and we have to integrate from minus infinity to plus infinity of one variable. Then we will get the other variable PDF. Okay, let's solve this example first. Okay, the example 4.7, the joint PDF of x and y is this one. This is the joint PDF, and the limit actually is given like this, from -1 to +1, and then y value is from x squared to 1. So look at this one. This actually is not a rectangle, but something else. What actually it is? Let's see this one. The limit is from -1 to +1, and then y is up to -1, but from x squared to -1. So remember one thing, this x square. So this y value actually equal to x square. So when y equal to x square, if you can see that when 1 is 1, when 2 it's 4, when 3 it is 9. So actually it is a kind of
Parabola.
parabola kind of thing. So it's a kind of things like this. So, and remember one thing, x value equal to plus or minus, there will be positive value of y. So actually we will have both direction case, and it is from up to 1, so it is actually up to this one. So this kind of uh, variable, or you can say this kind of limit we have in our particular example 4.7, and they're telling that this region we have a PDF of 5y by 4. Okay, 5y by 4. Now, how to find out this marginal PDF, fx or fy, whatever it is? When I'm talking about fx, then we need to find out the integration of dy, isn't it? We have to put this 5y by 4, no problem, and then we need to find minus infinity to plus infinity. So the thing is, outside this region there is no, I'm talking about the y, so outside this region there is no value of y. So it is actually from something like, it is from 0 to 1 kind of thing, but it is not 0 to 1, because then it will count all these areas. Okay, so what actually it is? So if I say that it is y, actually it is equal to x squared to 1, it is already given actually, and actually we can do it like that, because the x value, I mean the y value is actually variable. Huh? Y value is variable. If I say that x square, these points are x square. Okay, these are x square points, and the lower limit is x square, and then the upper limit is 1. So that actually works, no problem. So we can write 5y by 4 and then dy, and we can easily integrate and we can find the result. Okay, this is for finding of fx. But when I'm talking about fy, then how to do it? Definitely it will be dx, limit of x, and the limit of x is given here from -1 to +1. Remember one thing, actually what I need to find out is this one. What I need to find out is actually this one, isn't it? These values, these values, these values. So these are not actually always -1 to +1, because these are not always fixed. These are also variable. So if I want to say that this limit is from this point to this point, this point to this point, then actually we need to find out a variable. We know that this curve is y equals to x square curve. So if I want to find out the value of x, then that x value will be equals to root y, or you can say plus minus root y. If I say it is from minus root y to plus root y, so if I say that this is the minus root over y to plus root over y, and then this 5y by 4 will be there. Is it okay?
Yes, sir.
Yes, sir.
So this is the limit of our uh, x direction, and that will be actually whatever the calculation result will be, we can find out in that way. Okay, so these are the two PDFs, fx and fy, in this particular example. Let's see that how they have done. Their work will be the same. Okay, look at this, the fx, they have done x square to 1 f I by 4 by d, and then they have found out the result like this one, 5 into 1 minus x square by 4 by 8. Then also they have found out this, actually this one is a probability. When I'm talking about PDF, then we need to find out the zero otherwise case. So they have put it in PDF format, and they have done it like this. But what about the fy? Look at this fy. Fy is minus root over y to plus root over y, and then this value. After calculation, we have found out this is the result of this probability. That is the probability. So in the PDF format, we can have a different kind of thing, like the same thing. It is the same thing, but just with this probability and then zero otherwise value. Okay, so I think it is clear to all. Is it clear?
Yes, sir.
Yes, sir.
Okay. I'm talking about the functions of two random variable. Okay, functions of two random variable. And remember one thing, when I'm talking about the functions of two random variable, this w is the function of two random variable. So I'm talking about the w is a function of two random variable. If you can remember, in a single random variable case, we talked about y equal to fx. Can remember, y was a function of x. Then how do we find the PDF of y like this? So the same thing is here as well. This w is a function of two random variable x and y, and the PDF of w will be summation of those xy which are mapped in this gxy. So I will take those probability which are in between this w. Let's see an example, then it will be more clear. At first you read it. Example 4.8, you read it first. Okay, is it okay? Have you read it?
Yes, sir. Yes, sir.
Okay. So what actually is this one telling? A firm sends out two kinds of promotional fax emails. So actually, there are two kinds of fax. One kind of fax actually is something like it is only text, and another kind of fax, which one is actually which is the image. Image. Okay. So this text kind of page can be 1, 2, 3, and image kind of page also can be 1, 2, 3. Okay. So there are 6 options actually. Okay. Now they are telling that if I want to send one text page, that needs 40 seconds to transmit. But if I need to send an image page, that takes 60 seconds for transmission. Okay. So there are two random variable. One is L, another one is T. L is the length, T is the time. So length is telling that it can be 1, 2, 3, and also this one can be 1, 1, 2, 3. So the length dimension is actually something like this: 1, 2, 3. And when I'm talking about the time can also be something like all either 40 second or 60 second. All right. Okay. Now they have seen their previous record, and they have found out that this is the probability for different combinations. That if it is a one page text, then it takes 15% of this is like this. One page of image, it is up to 10%. So it is told that what are the distribution of these different kinds. And now they're telling a third random variable D, which is the multiplication of L and T. Okay, now they are finding out what is the range of SD, PMF of D, expected value of D. Can you do it?
Yes, sir.
Then try to solve it first, then we will discuss.
স্যার রেঞ্জ এসডি দিয়ে কি বোঝাচ্ছে?
রেঞ্জ এসডি মানে হচ্ছে যে ভ্যালুগুলো কি কি হতে পারে। রেঞ্জ মানে কি আমরা তো দেখছিলাম, we already have
জি
seen
স্যার।
what is range. Range is the possible values of that particular variable. Let me know when you are finished.
স্যার পিএমএফ আর এক্সপেক্টেড ভ্যালুটা একটু করে দিলে ভালো হতো।
আচ্ছা দিচ্ছি। Okay, so have you understood the range? What was the range?
স্যার ইজ ইট
SD
40 to 180?
40, 60,
Yes, sir.
80,
120,
120, 180.
180.
Okay, so this is the range.
Yes, sir.
All right. Now, if you understand that how to find the range, then let's go and move to the PMF. What is PMF? PMF is actually for different value, what are the probabilities if I put it in a table, that is the PMF, isn't it? So actually the probability values for different combinations is given. When you're talking about 40, SD
Yes,
equal to
sir.
40, 40 comes from where? 40 comes from 40 into 1. So that is the corresponding probability, 0.15, isn't it? So when I'm talking about that D value equals to
Oh, yes, sir.
40, then actually this is for 0.15. When I'm talking about D value is for 80, that means I'm talking about this 0.3, isn't it? When I'm talking about D value equals to 60, I'm talking about 0.1. When I'm talking about it is 120, remember one thing, 120 actually comes twice. 40 into 3 equals to
Yes, sir.
120, and again 60 into 2 equals to 120. So these two actually contributing to 120. So when I'm trying to find out the probability of 120, what will be that one? What
Sir,
will be the
0.2 plus 0.15.
0.2 plus 0.15, that is 0.35. Okay, then I'm talking about
Yes, sir.
180. 180. When it is 180, then it is 0.1, and then 0 otherwise. That is the probability of D, isn't it?
Yes,
That is
sir.
the PMF of the D
Yes, sir.
value. Okay, all right. Now, how to find out the expected value? How to find out? Tell me. You tell me now. How to do the expected value of D?
Sir, we multiply.
Probabilities into D.
Right, because this
Sir, we
probability into
multiply
D,
each PD
then
with
D
D
into D,
and add them.
right, and add them, summation. So very easy. 0.15 into 40 plus 0.3 into 80 plus something like that. This. Okay, and you can find out the expected value of D. Is it okay?
Yes, sir.
So I think we can do it.
Yes,
We
sir.
can solve it. All right. Let's clear and go to the next slide. Just to show you the result. These are the results, and this is the expected value to find out the um, resultant. 96 second. This is the expected value. Now let's go for this theorem 4.11. So in the theorem 4.11, we are having this if another function of random variable, which is a W, that is the maximum value of xy. Okay, what is the maximum value of xy? Remember one thing. Say for example, we are having this x and we are having this y, and say for example we are having some value like this, and remember one thing, W is for every value we can find the W, or for every value we can find the W. How? Say for example this value, say this value x value equals to 2 and y value equals to 1. So this W will follow x because x is the maximum. So W equals to 2. For this particular point, say x equals to 1.5 and y equals, x equal to 3, y equals to 1.5. So then W will be equal to 3. So W will follow the maximum between x and y, whichever is maximum. Okay. So if this is the function, then the CDF value will be like this: minus infinity to W, minus infinity to W, then fxy dx dy. Okay. So if it is like that, then an example is given, example 4.9. In example previous one example, we have seen this value. We have seen this thing 0 to 3 and 0 to 5, isn't it? And this area actually has a PDF of 1/15. And this is the fxy. So they're telling find the PDF of W equals to max of xy. So they are trying to find out the PDF. Very easily we can find out the CDF, because this is a function W equals to max xy, and from this function, this is the same function, so we can easily write directly this one, that CDF is the CDF is this value. If we can find the CDF, we can find the PDF as well, because by differentiation of CDF we can find the PDF. Okay, now the thing is, this problem is a complicated problem, and remember one thing, that there are two regions. One region is this one, where x value and y value are same. That means any value can be x and y, so they are well distributed. So if in this region we will write 0 to w and 0 to w, and then this 1 by 15 dx dy, and we will find the CDF. But in the other region, when it is 3 to 5, remember one thing, in this region the y value is fixed, 0 to 3, but x value will be changed because the variable is x, because in this region always the value of x is more than value of y. So w will always follow x. So for that particular, that is the region between 0 to w, when w value is 0 to 3. And if w value is 0 to 5 or 3 to 5, then the thing will be the x, the y value will be, this is dy dx, the y value will be 0 to 3 and x value will be 0 to w. Okay, and then that will be this 1 by 15 and then dx dy or dy dx. Let's see the solution. They are dividing it in two part. One is 0 to 3 when w value equal to, then they are finding the CDF equals to this much value, and when the w equals to 3 to 5, then they are fixing the y value, y range. They are fixing the y range 0 to 3, and x value, when it is, the w actually will depend on totally on x, not on y. That's why this x value variation from 0 to w, and that actually will give you w by 5. So there are two ranges. One is this one, another one is this one, and this CDF actually can be written like this, because when w is less than 0, then the CDF will be equal to 0. When w is more than 5, CDF will be equal to 1. We can understand this one. And these two range w CDF can be found out from these two equations. And when we have found out this CDF, now it is very easy to find out the PDF, isn't it? The PDF can be easily found out from this equation, and this equation is just differentiation of this CDF. Look at that, 0 is 0, 1, then this w square becomes twice w divided by 15, and w becomes 1, and you can easily find out that this is the this one is the PDF of that particular problem. Is it clear?
Yes, sir.
Okay. Let's go to the next. Okay. So the expected value. Now look at one thing. Expected value is something that we need to find out. Is this one? Why is it like this one? If you can remember the y equals to function of x, then how did we find out expected value of y? Can you remember? We told
Yes, sir.
that
The summation of
y
is into the probability.
of x.
Yes, sir. Yes.
This is the main thing.
Yes, sir.
So the similar kind of thing will happen here as well. When I'm talking to find out w, then what will I do? This summation, now the double summation will come because there are two random variables.
Yes, sir.
Then this pxy will come.
Yes.
And then this gxy or w, whatever it is, gxy, or you can write here w as well. Okay. So,
Yes, sir.
so this is the similar kind of equation that we have seen in the previous chapter. Okay. So for a discrete case, we will write this one, summation, double summation. For continuous case, we'll use the double integration. Okay. But this gxy into fxy, that is the main important point. Okay, look at this example 4.11. Try to solve this one. And then theorem 4.14 is telling that if x and y are two random variables, then expected value of x plus y will be expected value of x plus expected value of y. And then if I'm talking about the variance, that variance actually will have an extra value, an extra part. It is not like variance of x plus variance of y, but 2 into expected value of x minus mu x into y minus mu y. And remember one thing, this 2 in expected value of mu x minus mu y, I mean x minus mu x into y minus mu y, that is called the covariance of xy. So actually we are writing it like something like this one: variance of x plus variance of y plus 2 into covariance of xy. Okay, so this is the result of variance of x plus y. Okay, so what is covariance? That's the same thing that I told you. The covariance is actually when I'm talking about the variance, that actually is variation of random variable from the mean, isn't it? If you can remember, if you can just remember this variance equation, x minus mu x square, can you remember? So this was the same x random variable. Variance means variation in the same random variable. But if I change this one, that say for example, that means this is the same, isn't it? This is the same as that one. Now, if I say that e of x minus mu x into y minus mu y, then that will be called covariance. That means variation of one random variable with other random variable. One variance with the variance of other. This is the covariance. But when the variance is same, is in the same random variable, this is called variance. Clear?
Yes, sir.
Okay. Now the thing is, this is the covariance, I told you already. And then correlation, another term, correlation is there. That correlation is Rxy equals to expected value of xy. So if we have two random variable, if we multiply them, and then if we take the expected value, then actually we are finding the correlation. Okay, so this is the correlation case. Now we have some theorems. Some theorems we have. This covariance of xy will be equals to correlation minus mu x into mu y. Then variance of x plus y, already we have seen, equal to variance of x plus variance of y plus 2 covariance of xy. Then another term is there. If actually we were talking about covariance, that means there are two random variable, but if somehow those two random variables become a single one, that means x and y is equal, then this covariance will become the variance. Covariance becomes variance of x or variance of y, and this correlation becomes expected value of x square. This is what? Second mean. Second mean. Okay. So this remember that if x and y are equal, then actually it is the variance of the covariance becomes variance and the correlation becomes second mean. Okay. Is there any question?
No, sir.
Okay. Let's solve this example 4.12. Very easy example. Okay, very easy example. You try first. You try first. Just I have shown some theorems, and with those theorems you can easily do it. Try. Can you do it? At first, try to find out the correlation. Isn't it? The basic equation for correlation is expected value of xy. Now, expected value of anything equal to that particular value multiplied by their probability, and then summation. So if it is like that, actually we have already some values, x and y values, and their corresponding probabilities. So we have actually 4 probabilities. So definitely we have 4 equations to, 4 multiplications to do with their xy values. When I'm talking about this 0.01, its corresponding value is x equal to 0 and y equal to 0. So if x equal to 0 or y equal to 0, if you put and multiply with this probability, that will be equal to 0. Isn't it?
Yes, sir.
So we don't need to put it here. Then that one, its value is x equal to 1, y equal to 0. Again, y equal to 0 is there. So if you put it here, that will become 0. Isn't it?
Yes, sir.
Then y equals to 1. This y equals to 1. So here y equals to 1 and x equals to 1. So now you put the value of x and y and px. X value is 1 into y value is 1 into px value is 0.09. Then plus that one, x value is 2, y value is 2. So 2 into 2 into 0.81. Are you finding it okay?
Yes, sir.
Yes, sir.
Okay. We have not put those 2 points because one of the xy values are 0. So any one value is 0, then actually the whole value will be equal to 0. So that one will be 0.09 plus 4 into 0.81. That is 0.09 plus 4, both 3.24, 3.33. Okay. So this is the value for correlation, isn't it?
Yes, sir.
Okay. So if it is like that, now how to find out this covariance? Covariance, we have an equation, isn't it? Previously we have seen that this correlation minus mu x mu y, isn't it?
Yes, sir.
In the previous 3, in one theorem there were 3 equations, 3 you can say 3 rules given, and one of the rules is this one: covariance of xy equals to correlation minus mu x mu y. What is mu x mu y? Mu x is expectation of x and mu y is expectation of y, isn't it? Now from this we have actually know the px value. Px values are given and the x values are also known. So if I know that, we can easily find out the ex equals to mu x equals to what? 0 into 0.01 plus 1 into 1.18, 0.18 plus 2 into 0.81, and that value will be equals to 0.18 plus 2, 1.62, and then, isn't it? Okay. 0, 8, 1. 1.8. So 1.8 is mu x. Similarly, you can calculate the mu y as well, isn't it? You can solve
Yes,
it,
sir.
mu y. Tell me, what is mu y? What is mu y?
So 0 into 0.1, 1 into 0.09, and 2 into 0.81.
9 plus 1.62. That means 1.71.
71.
This is mu y is 1.71, mu x is 1.8, and then correlation is 3.33. So it will be what?
So
So that will be
3.33 minus 1.8 into
3
1.71.
minus
1.8.
1.8 into 1.71. So whatever the result is it okay?
0.252. Yes, sir.
Is it okay?
0.252. Yes, sir.
Okay. So this is the how actually we will solve it. This is 3.33 and then 1.8, 1.71 and then 0.252 covariance value. Okay, is there any question?
No, sir.
Okay, if there is no question, then let's go to the next slide. Very important thing, important two things actually. Very important two things, that is, one is the orthogonal random variable, another one is uncorrelated random variable. Remember one thing, it seems like if the correlation value equal to 0, it means it seems like they are uncorrelated, but that is not true. If the correlation equal to 0, that doesn't guarantee that they are uncorrelated. It means they are orthogonal. Okay, when the correlation value equal to 0, they are orthogonal, and when the covariance equal to 0, they are uncorrelated. Very important things to remember. What is orthogonal? Do you have any idea what is orthogonal?
So 90-degree apart from
Right,
each other.
90 degree apart from each other. So if x and y are 90 degree apart from each other, that means there is no projection of one variable over another variable, and that is called orthogonal. So if they are spaced like this, then I can say that their rxy will be equals to 0. And if their covariance equal to 0, that means we can say that they are uncorrelated. Okay,
Yes, sir.
telling it up to this portion, we are ending this class, today's class. In the next class, we will finish chapter 4 and we will start chapter 5 as well in the next class. Okay, so today we are stopping here, and I want to see if there are any question or not. If there are any question, you can ask. So if there is no question, maybe we can close today's class and let